This tutorial provides a brief description of the buttons, options and reviews that you will encounter in this course. When you launch the course, there are tabs on the left side of the course's screen, and controls on the bottom. Every course contains at least 2 tabs on the left side of the screen. One is Menu, and the other is Notes. The Menu tab acts as a table of contents, and shows the titles of all the slides in the course. You can select a slide, and the course jumps to the selected slide, the AC/DC power units in this example. On a slide, you can follow along with the audio by clicking on the Notes tab. The Notes tab contains information about the topic being discussed, and the text on this tab typically matches the audio. There are several buttons at the bottom of each slide that provide navigation through the course. Clicking the next button advances to the next slide in any lesson, not including the review questions. If you wish to revisit a slide, either click the previous button, or go directly to a slide using the Menu tab, then select that slide from the menu. At the bottom of each slide is a progress bar. The bar advances with the audio. If there is no audio for a slide, the progress bar has no function. If there is audio, you can click anywhere on the progress bar to go to that point in the audio for that slide. In this tutorial, the audio for the slide is muted, so you can hear this tutorial. Next to the progress bar is the Start Pause button that allows you to start or pause the slide by clicking it. The course is divided into lessons. Each lesson has slides that will discuss the content for that lesson, followed by a lesson review that consists of a series of questions. If you answer a question correctly, a pop-up window tells you so. If you answer incorrectly, a pop-up window says you answered incorrectly. It has a blue button labeled, "Click to see slide with correct answer," that takes you back to the page that has the correct answer to the question. After reviewing the correct answer, a small blue button appears, which returns to the question. When you get to the final review, if you answer incorrectly, a pop-up appears with a gray "Incorrect." You must click the Continue button, as the final review must be completed before seeing the correct answers. After answering all the final review questions, click the Review Questions button to see the results of the final review. The questions, with the answer you chose, display one at a time, and tell you if your answer is correct or not. If your answer is incorrect, the correct answer is identified by a green check mark. Click the Next button to go to the next question. After you have reviewed all the questions, you are taken back to the results page. Click the Course Complete button to exit the course.
This lesson provides an overview of the system and describes the main functions of its components and connectors. It also covers the system configuration that the provisioning examples in this course are based on.
Using the information contained in this lesson, students should be able to identify L-series hardware components and connectors, and their main functions, as described in the L100 L-series user manual. The L100 L-series delivers carrier-grade, next-generation, colorless, directionless, CD, reconfigurable optical add-drop multiplexer ROADM functions, in compact 1RU enclosures. Any wavelength can be assigned to any port on any degree, and customers have connectivity to any degree from a shared add-drop side. Up to 2 degrees of CD ROADM is supported, shown on E1 ports in the figure, with up to 32 add-drop 100 gigabits per second channels. The figure shows these 32 channels as E1 through 16, on 2PI L1-3PS2, plug-in units. The L100 L-series consists of 2 types of blades. One type is a 1x9 wavelength selectable switch ROADM on a blade, BDL1-3R11. The second type is an optical multiplexer base blade, BDL1-3B11. These blades, in the disaggregated option, can be mounted in a 19-inch or 23-inch, 2-post or 4-post rack. In the aggregated option, they can be mounted in a 6-blade housing. This figure shows a basic block diagram of the blades and plug-in units, PIUs, used in a 2-degree 1-finity L-series ROADM deployment. The following is a brief description of the devices depicted. The 1x9 WSS, ROB, BDL1-3R11, is required for each degree of ROADM and supports the following. A single edge port, E1, that supports a single degree. 9 customer side ports, C1 through C9, that support either a pass-through port, C1 in this example, to another degree, or that support customer ports, that connect to edge ports on one of two 4x16 splitter coupler PIUs in the optical mux base blade, BDL1-3B11. Release 1.1 supports up to 32 add-drop 100 gigabits per second channels from two 4x16 splitter coupler PIUs, PIL1-3PS2. The optical mux base blade, BDL1-3B11, supports one or two 4x16 splitter coupler PIUs. Each PIU multiplexes up to 16 clients, and sends them to both degrees via one of its 4 edge ports, E1 through E4. At each 4x16 splitter coupler PIU, a cable from one of its edge ports, E1 and E2 in this example, is connected to one of the client ports, C8 and C9 in this example, on a 1x9 WSS, ROB, BDL1-3R11. The add-drop circuits from the BDL1-3R11's client ports are mapped to a channel on the edge port of the BDL1-3B11 blade. Pass-through circuits between ROADM degrees can be connected through a client port, C1 in this example, on the BDL1-3R11 blade at each degree, to a client port, also C1 in this example, on the BDL1-3R11 blade at the other degree. Future releases, from Release 3.1, support Open ROADM, which specifies a common optical interface between nodes, and a common management plane protocol, that uses industry-standard YANG models for provisioning. This figure shows the L100 L110 configuration, that the provisioning examples in this course are based upon. In this figure, note the following. Management, a CLI session, occurs on the L100, through the LCN1 port. The 1x9 WSS, ROB, in the L100 is logically shelf 1, slot 0. The 4x16 coupler splitter in the L110 is logically shelf 2, slot 1. The L100 has a single degree through its E1, edge 1, port. The L100 has an OSE port physically connected, cabled, to one of the following two ports. E-SE-E1. When connected to this port, it makes the OSE an Ethernet interface that supports provisionable speeds from 125 megabits per second to 1.25 gigabits per second. F-SE-E1. When connected to this port, it makes the OSE an OC3 interface that supports 155 megabits per second. The E1 port on the L110, 4x16 coupler splitter PIU is connected to the C1 port on the L100, 1x9 WSS, ROB. C1 on the L110 is connected to a flashwave CDS. C2 on the L110 is connected to a 1-finity T310. This example shows the customer devices being flashwave CDS and 1-finity T310. Other nodes are supported by the L110, these are just used as examples. For a complete listing of the devices supported by the L110, refer to the L-Series User Manual. There are 4 SFP-based management ports on the front panel of the L100, 1x9 WSS, ROB, that support IPv4 and IPv6, and auto-sensing port speeds from 10 to 100 megabits per second. LCN1, Local Communications Network 1 port supports remote access, where a default gateway can be provisioned, and it supports one IPv4 address. The default IPv4 address is 0.0.0.0. LCN3 and LCN4 are used to daisy-chain the management plane from one L100 to another. When daisy-chaining, LCN3 on one node connects to LCN4 on the next node. The LMP, Local Management Port, supports the following. Local access only. No default gateway is available. One default IPv4 address of 192.168.1.1/24. The management PC must have an IP address in the 192.168.1.0 subnet. One additional IPv4 address can be provisioned. There are two databases maintained on the L100. One database is the Candidate Configuration Database. This is a configuration database that can be manipulated without impacting the device's current configuration. When you issue the CLI command commit, it saves any new CLI provisioning to the running configuration database. The other database is the running configuration database. It is a configuration database that holds the complete configuration currently active on the device. The running configuration database always exists. After the database is provisioned, it is stored on the L100 in the /var/ftp directory. The L100 can be managed in the following four ways. 1. CLI. There are two CLI modes of operation. The first mode is operation mode. This contains primarily commands that provide operational tasks or status. For example, the command string show interfaces displays the status of all interfaces. The second mode is configure mode. After entering the command string configure, different commands are available, but some of the same results as operational mode commands can be obtained. For example, the configuration mode command run show interfaces displays the same information as the operational mode command show interfaces. 2. Web GUI. A GUI interface is available in Release 1.1. 3. netconf. This is a non-text-based interface used by SSH-based operational support systems, like Fujitsu's Virtuaura, and is available in Release 1.1. 4. SNMPv2c. This is a management surveillance protocol that supports alarms, PMs and traps, and is available in Release 1.1. No provisioning is currently supported via SNMP. To manage or provision L-series nodes, a management device establishes a session with the L100 through one of its management ports. This course covers the L100 and L110, and this example shows a standalone L100 and its two management ports. The LMP, Local Management Port, is an Ethernet interface that provides management from a local laptop. The LMP has a default IP address of 192.168.1.1/24, so the connected laptop must have an IP address in the 192.168.1.0 subnet. The LCN1, Local Communications Network 1, is an Ethernet interface that provides management from either a local or remote device, using a provisionable default gateway. The LCN1 port has a default IP address of 0.0.0.0, which must be provisioned through the LMP port initially. After the database is provisioned, it is stored on the L100 in the /var/ftp directory. A remote user logs into the LCN1 port that is connected to the DCN, giving them access to the node shown at the top of this example. The management plane of the top node is then daisy-chained to the other two nodes in this example, using the LCN3 and LCN4 ports as shown. LCN3 on one node connects to LCN4 on the next node in the chain, but the last node in the chain does not connect back to the first node. Note: only one public IP address is required for this configuration. Another management plane option use is the Onefinity C200 Communications Integrator, as the main processor for all of the L-series devices, to which it is connected. A remote management device accesses the L-series equipment via the P1 port on the C200. The C200 then provides connectivity for up to 18 L-series devices, via ports 13 through 30. When backups are made, one copy is stored in the C200, and a second copy is stored on the first L100, that was activated on the C200. Note, only the C200 requires a public IP address in this configuration. The OSE provides remote management of nodes through a gateway node, GNE, which is the node connected to the DCN for remote access. After logging into the GNE, other nodes in the network are managed through the OSE channel that interconnects all nodes in the network that require management. The OSE port must be physically connected to either an E-SE-E1 port or an F-SE-E1 port when supporting their respective OSE channels, as described below. An E-SE-E1 is an Ethernet SFP port that provides a 1.25 gigabits per second or 125 megabits per second optical interface to, from, the OSE port. F-SE-E1 is an OC3 SFP port that provides a 155 megabits per second optical interface to, from, the OSE port. The 1x9 WSS, ROB, BDL1-3R11, has 9 client ports, C1 through C9, and 1 edge port, E1, and includes a built-in universal amplifier. For Release 1.1, up to 32 add-drop, 100 gigabits per second channels at 50 GHz channel spacing are supported, and 1x9 WSS, ROB, is required for each degree of ROADM. The 9 client ports can be provisioned as follows. Interfaces to an edge port on the L110, 4x16, splitter coupler. Pass-through ports from one degree to another. The onboard WSS, wavelength selectable switch, provides cross-connects for the optical circuits. 2 cross-connects are made, one RX and one TX, for each bidirectional service. The optical mux base blade, BDL1-3B, 11, houses up to 2, 4x16, splitter coupler PIUs, PIL1-3SP2. Slot 1 and 2 can each contain an optical mux blade. Each PIL1-3SP2 provides client ports for up to 16, add-drop, 100 gigabits per second channels. A filler panel is available, and must be installed for proper cooling in any unoccupied PIU slots. 1. BDL1-3B11 blade can be installed to provide the 32 available add-drop channels to each of the 2 available ROADM degrees that are supported in Release 1.1. Up to 2, 4x16 splitter coupler PIUs, PIL1-3SP2, can be installed in each optical multiplexer base blade, BDL1-3B11. PIL1-3SP2, PIU, provides client ports for up to 16 add-drop, 100 gigabits per second channels. 1 BDL1-3B11 blade can be installed to provide the 32 available add-drop channels to each of the 2 available ROADM degrees, supported in Release 1.1. Ports C1 through C16 are client-side, add-drop ports, and connect to optical customers. Ports E1 through E4 are edge ports, that provide connectivity to client ports on the 1x9 WSS ROB. All client ports on the 4x16 splitter coupler are permanently connected to each of the edge ports, and each edge port can be connected to one ROTM degree, a 1x9 WSSROB. To support 2 degrees, 2 edge ports are provisioned. With 4 edge ports, up to 4 degrees are possible. Note: currently only 2 degrees are supported. The fan units provide cooling for the entire blade, and have the following features. 2 replaceable fan units, each hot swappable and containing 2 fans. An LED for each fan unit on the back panel that, when lit green, indicates that 12.5 DC power is applied to the blade, and that the fan units are operating normally. Fan equipment is auto-provisioned. Failure of a single fan unit is not service affecting over the operating temperature range. From an alarming and provisioning viewpoint, there are 4 fans, fan 1 through fan 4. From a mechanical standpoint, there are 2 fan units. Each fan unit houses 2 fans. Fan 1 fan 2 are housed in one fan unit, and fan 3 fan 4 are housed in the other. A fan unit is the removable and replaceable entity, not the fans. There is also an ESD connection point for an ESD wrist strap on the back panel. The L100 supports negative 48 volts DC, input only, using a power terminal adapter. One power terminal adapter is required when a 1-finity blade is installed using the disaggregated option. The power terminal adapter provides dual, negative 48 volts DC, A and B, power feeds to the blade. This lesson provided an overview of the basic functions of L-series major components, including the following: 1x9 WSS ROB, optical mux base blade, 4x16 splitter coupler, management interfaces, OSC interfaces, power terminal adapter, fans.
This lesson provides an overview of the system and describes the main functions of its components and connectors. It also covers the system configuration that the provisioning examples in this course are based on.
Using the information contained in this lesson, students should be able to describe L-series installation steps for a 19-inch rack, as described in the 1-finity L100 user manual. This installation example shows how to install a single L-series device in the 19-inch rack. The entire procedure is repeated for each L-series blade you install. The only physical installation differences between the blades is the number of PI used to install. First, determine which rack mounting bracket is the left bracket, and which is the right bracket. Each is labeled left or right, as shown in the figure. Next, loosen the flange screws on both the left and right brackets, but do not completely remove the screws from the flange. Finally, adjust the width between the front flange and rear flange on both brackets, to the width of the rack. Use the front flange on each bracket to attach the brackets to the front of the rack at the required position, as shown in the figure. Do not completely tighten the bolts. They will be completely tightened later in the procedure. Use the rear flange on each bracket to attach the brackets to the rear of the rack at the required position, as shown in the figure. Again, do not completely tighten the bolts. They will be completely tightened later in the procedure. Verify that the front and rear flanges on each bracket are installed in the correct rack position. Verify that the installed brackets on the 19-inch, 4-post rack are spaced 440 mm apart, and that the brackets are level, as shown in the figure. Note: confirm that the bracket spacing is correct at the front and rear of the rack. Use the bolts on the flanges to adjust the spacing and tilt of the brackets if required. Tighten all bolts completely on each bracket. Each bracket is mounted to the rack using 4 bolts, 2 in front and 2 in back. Tighten the flange screws on both the left and right brackets, as shown in the figure. Note: do not use excessive force to tighten the nuts and screws. Remove the protection cover from the power terminal adapter. Attach the power terminal adapter by inserting the hooks on the power terminal adapter into the holes on the rear of the blade. Push the power terminal adapter until it meets the rear of the blade. Push slightly on the power terminal adapter to properly seat the adapter on the blade. Review the position of the power terminal adapter on the blade. Verify that no gap exists between the power terminal adapter and the blade. Also verify that the power terminal adapter is slightly below the top of the blade. On a flat ESD-safe surface, carefully tighten the attachment screws to secure the power terminal adapter onto the blade. Alternate between the 2 screws as you tighten them, rather than tightening one screw completely and then the other screw. Take care not to over-tighten them. Warning: the attachment screws mentioned in this step must be lined up straight in the holes and should easily turn right up to the point of being tight. If any resistance occurs in the first turn, stop immediately, or risk damage to the blade, such as broken screws and screw holes on the blade. Replace the protection cover on the power terminal adapter. The blade is heavy and should be handled carefully. Do not use the fiber management arms to lift and install the blade. Doing so may damage the blade, causing the blade to fall, resulting in personal injury. When lifting or installing, use 2 hands positioned at the center of the blade to avoid dropping it. At the front of the rack, lift and align the blade's inner rails with the bracket outer rail, as shown in the figure. Fujitsu recommends installing the blade without the PIUs installed. Insert the blade in the bracket track, and slide it back until it locks in place. Unlatch the fiber restraint gates on each side of the blade by sliding the fiber restraint gate slightly inward. This opens the gate. After opening the fiber restraint gates, secure the blade to the rack using the set screws on the left-hand and right-hand sides of the blade. Note: the set screws for securing the blade are accessible after opening the fiber restraint gates. Remove the protection cover from the power terminal adapter. Attach the power cables to the power terminal adapter. Warning: if you are stacking multiple blades in a rack, make sure to use terminating cable lugs bent at 90 degrees. Otherwise, the cables will make contact below the power terminal adapter. Fan filters are not required for individual 150 blades using the disaggregated option. For 150 blades installed in the 150 housing using the aggregated option, the housing includes an air filter to protect all of the blades in the housing. The housing air filter should be replaced every 90 days. Insert the fan unit into one of the slots located on the back of the blade, and press until the fan unit locks in place. When the fan unit is inserted, the fans should start running, and the fan LEDs on the rear left side of the blade should light green. There are 2 fan LEDs that give fan unit status on the back panel of L-series blades. Warning: ensure that an appropriate ESD wrist strap is worn and that it is properly grounded. Each PIU has a locking lever that has 3 functions. First, it acts as a stopper to prevent damage to the PIU or blade connector in case the PIU is inserted using too much force. This function only works when the locking lever is in the locked position. Second, the locking lever helps to properly align the PIU and blade connectors during insertion. Third, it locks the PIU in place after complete insertion. Ensure that ESD handling precautions are observed, and remove the PIU from its ESD protective packaging. Inspect the PIU for any damage or debris. Carefully remove any debris. If the PIU is damaged, follow local procedures for repair or replacement of a damaged PIU. Do not proceed unless the PIU to be installed is of the correct type and is undamaged. Verify that the locking lever is in the locked position. Carefully align and insert the PIU into the appropriate slot until it stops. Note: the PIU should be slowly and carefully inserted into the blade, to prevent damage to the PIU or blade. Damage to the PIU or blade is more likely if the locking lever is in the released position. Rotate the locking lever to the released position, and gently press it in, until the lever automatically starts to move, as shown in the figure. Rotate the locking lever to the locked position to fully insert the PIU, and lock it into place. Warning: to prevent damage to the PIU, never force a PIU into position. Note: make sure that the locking lever locks in place. If the locking lever is hard to lock into place, press the release button in the middle of the locking lever and try again. 7. Install and secure the SFP module into the proper port on the front of the PIU. Warning: do not push the module too quickly into the port on the front of the PIU. Seat the module with a slow but firm motion, to avoid damage to the module or port. Clean the optical connectors. Connect the fiber optic cables to the SFP. This lesson provided the steps used to install an L-series blade into a 19-inch rack, to include the following: rack mounting brackets, power terminal adapter, fans, blade, PIUs, SFP.
This lesson, Turn Up Using CLI, you will see the provisioning steps and parameters for turning up an example system. It addresses logging in with the terminal emulation software and gives you examples that include provisioning components, creating and managing user accounts, and saving configuration changes you have made.
Using the information contained in this lesson, students should be able to recall L-series provisioning steps and parameters for the turn-up of an example L-series configuration, as described in the Onefinity L-series user manual. The L-series CLI command line interface has the following features: a command line editor with command history. Characters are case-sensitive. Context-sensitive help, which means that after entering a command parameter, a question mark can be entered. This returns a list of allowable parameters, with explanations of parameter variables. Command completion means that after a parameter has been partially entered, pressing the tab key completes the parameter, if those characters are part of a specific parameter. Command hierarchy, where configuration commands are nested within higher-level configuration commands. When in the configure mode, that is, when you are configuring the database, the command commit must be issued to copy the provisioning from the configuration database to the running database. In other words, the commit command saves database changes. Log into the L100 using a terminal emulator such as PuTTY, which is shown in this example. Enter the IP address of the L100 in the field labeled hostname or IP address. The default IP address is 192.168.1.1/24. The L100 uses SSH, Secure Shell, by default, on port 22. After the terminal emulator connects to the L100, the prompt, login as, is displayed. If this prompt is not displayed, check the IP address that you entered in the terminal emulator, and ping the IP address to check connectivity to the L100. At the prompt, enter a valid username and password. The default username is Fujitsu, and the default password is Onefinity. The password is not displayed when it is entered. If the username and password are a valid combination, the system name is displayed. In this example, the system name is Fujitsu-Core 1. The L100 supports up to 25 concurrent users. All users can use the same logon credentials with the following restrictions: no more than 10 netconf users, no more than 10 CLI users, no more than 5 SNMP users. L-series equipment is provisioned from the configuration mode. from the system prompt, enter the configuration mode by using the command configure. In this example the system prompt is Fujitsu-Core 1. If the L100 is new, right out of the box, it may power up in private mode, which means it will not be possible to enter the configuration mode until the following command string is issued. Request set-shelf mode, shelf role main, shelf ID 1. Entering this command will generate a prompt that states, the database will be erased. Really want to do this? No, or yes? You must answer yes, after which, the node reboots and the CLI session terminates. When the reboot is complete, log on to the default IP address. There is always a default user account on the L100. The username of the account, all in lowercase, is Fujitsu. The password is onefinity, spelled using the numeral 1, followed by finity, also all in lowercase. This account cannot be deleted even if the command, delete all, is issued. Although the account cannot be deleted, the password can be changed. While in the configure mode, the command, show users, shows all the users, who are currently provisioned on the L100. The information is displayed in the following format. User displays the username. The username in this example is Fujitsu. Crypt password. Users can be provisioned with all or without password encryption. When the crypt password parameter is used, password encryption is enabled for this user. This means that the password will not be displayed when the user account is displayed, and the password will be encrypted when it is transmitted across the DCN or OSC. Group defines the capabilities of an account, and comprises level 1 through level 6. Level 1 has read access only. Level 2 can perform basic provisioning tasks. Level 3 can perform basic provisioning tasks with LED control. Level 4 is a super user account. It has access to all of Yang database, and can issue any of the commands. Level 5 has all privileges, except security. Level 6 has security privileges only. Admin state enables or disables this user account. When not in the configure mode, the show users command string displays all the users who are currently logged onto the L100. The command set users user provisions a user account. In this example, the username is test01. The password is configured to be encrypted. The password is training01. The T in training is uppercase, so that is how it must be entered when the user logs in. User test01 has privilege level 4, and can edit the database as needed. The user's admin state is allow, which means the account user has access to the database when logged on. After entering the command to provision a user, the command commit is used to copy the provisioning from the configuration database to the running database. To display the new user test01, use the command show users user test01. The command delete users user deletes a user account on the L100. In this example, the user account being deleted is test01. After entering the command to delete a user, the command commit is used to copy the provisioning from the configuration database to the running database. To display the current users, use the command show users. In this case, the user account named test01 has been deleted and will no longer be displayed. The example shows how to set the TID, which will uniquely identify this node from others in its network. The TID is set with the command set wdmcfg tidnum, and then providing a TID number when prompted by the system. In this example, the numeral 1 is entered as the TID number. The TID could also be set in the command itself, with the following syntax. Set wdmcfg tidnum 1. After entering the command to provision the TID, the command commit, is used to copy the provisioning from the configuration database to the running database. To verify the TID, use the command show wdmcfg tidnum. The system name is displayed in the command prompt and on the welcome screen when logging on. In this example, the system name, Fujitsu, is changed to Fujitsu Training. To set or change a system name, use the command set system name. Next, use the command commit to copy the provisioning from the configuration database to the running database. After setting the system name, the system must be rebooted. The L110 optical mux base blades, BDL1-3B1, 1, are provisioned as tributary shelves, or TRIB. In this example, a single L110 is defined as tributary shelf 2, since the L100 in this example is shelf 1, which is the main shelf. If a second L110 is provisioned for the L100, it will be defined as tributary shelf 3. This tributary shelf is also placed in service with the admin status up parameter. Now the LCN1 port needs to be defined for the network in which it is deployed. First, this example shows LCN1 being defined as an Ethernet interface, Ethernet CSMACD. It has a port speed of 1 megabits per second, using the parameter speed 1000, and is placed in service admin status up. After entering the command to provision the protocol and speed for LCN1, the command commit is used to copy the provisioning from the configuration database to the running database. Next, the LCN's IP address and subnet mask are defined for the DCN network, to which it will be connected, as shown in the example. The example shows the LCN1 port, which is named IP-1/0/0/LCN1, being provisioned as follows. Forwarding is enabled by using the parameter true. If the parameter false is used, the LCN discards all frames that should be forwarded externally. The IPv4 address is 10.1.101.70. Using the prefix length 24 parameter, the subnet mask is /24, which is 255.255.255.0. After provisioning the IP address and subnet mask for the LCN1, the command commit is used to copy the provisioning from the configuration database to the running database. After the commit is done, as shown, the LCN1 port loses communication with any connected devices, as it reprograms to the new configuration. You must change the IP address of the laptop used to log on to the node, so that it uses the same subnet as the LCN1, which is 10.1.101.0, in this example. When the LCN1 port is connected to a router, allowing external access to the DCN, it requires a static route. This route is user-defined. In this example, the static route for the LCN1 port is defined as follows. The name of the routing instance is MCN. The routing instance, in this example, uses a single static route. The name of the static route is FNC, and it supports IPv4 addresses. 0.0.0.0/0 will route everything, all response to events or CLI requests, out the LCN1 port, which connects the L100 to the remote management device. 10.1.101.254 is the next hop address, which is the address of the router connected to the LCN1 port. This makes it the destination, that is, the next hop, for any packets transmitted out the LCN1 port. The next hop IP address, and the LCN IP address, must be in the same subnet. After provisioning the LCN1 static route, the command commit is used to copy the provisioning from the configuration database to the running database. This example shows how to set up an NTP, Network Time Protocol, server to control date and time on the L100. In the example, the NTP server name is Gremlin, and the IP address is 10.1.5.5. After provisioning an NTP server, the command commit is used to copy the provisioning from the configuration database to the running database. Date and time can also be set on the L100, so that it uses its own clock. To set the date to November 1, 2016 and the time to 4:55 p.m., use the following command. Request set current date, time, 2016-11-01 T16:55:00. After provisioning the date and time, use the command commit to copy the provisioning from the configuration database to the running database. This example shows how to set up a redundant NTP server in case of a failure of the first one. The second NTP server is set up the same as the first, by defining the name and the IP address of the second NTP server. After provisioning the second NTP server, use the command commit to copy the provisioning from the configuration database to the running database. Next, the fans are enabled. This example shows how to enable fan 1 and fan 2 in shelf 1. The card type for a fan unit is AC0, 0-F0, 1, 1. After enabling fan 1, use the command commit to copy the provisioning from the configuration database to the running database. Repeat these steps to enable fan 2. An L-series blade comes out of the box with one client port and one edge port enabled in the database. If additional ports or functionality is needed, an individual licensed feature, ILF, must be purchased and downloaded to enable it on the L-series blade. There are also temporary licenses that can be turned on without a download. These temporary licenses are valid for a trial period of up to 60 days. If the trial period expires, the temporary licensed entity must be deleted, or a permanent license loaded. Otherwise, the database will be locked, which will not affect traffic. To view any licenses that have been applied, use the following command. Show licenses status, license status. The response shows the number of licenses that are applied. In this example, 3 licenses are applied. Licenses are turned on with keys, and a key is an ILF. The provisioning examples that follow are based on the example configuration shown, which uses the L100 and L110 devices. The L100 is managed through the LCN1 port, and has a single degree via its E1 port. It uses the OSC, that is cabled to the E-SC-E1 port, therefore it is Ethernet. It uses the C1 port to interface to the L110, for add-drop traffic. And the L100 is logically shelf 1, slot 0, and has a single, 1x9, WSS, ROB. The L110 uses the C1 port, to interface to a FlashWave CDS. It uses the C2 port, to interface to a Onefinity T310. And the L110 is logically shelf 1, slot 1, and uses the 4x16 splitter coupler, in slot 1. The E1 port on shelf 1, which is the 1x9, WSS, ROB blade, BDL1-3R11, is the interface to the WDM network, and provides a single-degree ROADM. This example shows how to provision the E1 port on this blade, using the following parameters. Shelf 1 is the BDL1-3R11. Slot is always set to 0 on this blade, since it is a single blade, and all ports associated with it are on slot 0. Admin status is set to up, which enables the port. Edge defines the E1 port as the network port. NUM-lanes defines the number of WDM channels that the E1 edge port will support. In this example it is 96. After provisioning the E1 port on the blade, use the command commit to copy the provisioning from the configuration database to the running database. The C1 port on shelf 1 connects the 1x9 WSS ROB card, which is card type BDL1-3 R11, to the E1 port on the 4x16 splitter coupler PIU card, which is card type PIL1-3 SP2. The purpose of connecting the ports in this way is to support add-drop functions. This example shows how to provision the C1 port on this blade, using the following parameters. Slot is always set to 0 on the 1x9 WSS ROB. Since it is a single blade, all ports associated with it are on slot 0. Admin status is set to up, which enables the port. Client defines the C1 port as a customer-side port. NUM lanes defines the number of WDM channels that the C1 client port supports. In this example, the C1 client port supports 96 WDM channels. After provisioning the C1 port on the blade, use the command commit to copy the provisioning from the configuration database to the running database. The optical multiplexer base blade, BDL1-3B11, houses up to two 4x16 splitter coupler PIUs, PIL1-3 SP2, that can be installed in either slot 1 or slot 2. This example shows how to enable the PIL1-3 PS2 blade in shelf 2, the optical multiplexer base, slot 1, which is the physical location of the installed PIL1-3 PS2. After enabling the PIL1-3 PS2 PIU in shelf 2, slot 1, use the command commit to copy the provisioning from the configuration database to the running database. The E1 port on the PIL1-3 PS2, in slot 1 of the optical multiplexer base blade, connects to the C1 port on the 1x9 WSS ROB, to support add-drop functions for all client ports on the PIL1-3 PS2. This example shows how to define and enable the E1 port using the following parameters. Shelf 2 is the BDL1-3B11. Slot 1 is the physical location of the installed PIL-3 PS2. Admin status up enables the port. Edge defines the E1 port as the network port relative to the installed PIL-3 PS2. NUM-lanes defines the number of WDM channels that the E1 edge port supports. In this example, the number is 96. After provisioning the E1 port on the PIL-3 PS2 PIU, use the command commit to copy the provisioning from the configuration database to the running database. The C1 port on the PIL1-3 PS2, in slot 1 of the optical multiplexer base blade, connects to a flashwave CDS in the example network being provisioned. This example shows how to define and enable the C1 port on the PIL1-3 PS2 PIU in slot 1 using the following parameters. Shelf 2 is the BDL1-3B11. Slot 1 is the physical location of the installed PIL1-3 PS2. Admin status up enables the port. Client defines the C1 port as the client-side port. NUM-lanes defines the number of WDM channels that the C1 client port supports. After provisioning the C1 port on the PIL-3 PS2 PIU, use the command commit to copy the provisioning from the configuration database to the running database. The C2 port on the PIL1-3 PS2, in slot 1 of the optical multiplexer base blade, connects to a flashwave CDS in the example network being provisioned. This example shows how to define and enable the C2 port on the PIL1-3 PS2 PIU in slot 1 using the following parameters. Shelf 2 is the BDL1-3B11. Slot 2 is the physical location of the installed PIL1-3 PS2. Admin status up enables the port. Client defines the C2 port as the client-side port. NUM-lanes defines the number of WDM channels that the C2 client port supports. After provisioning the C2 port on the PIL-3PS2 use the command commit to copy the provisioning from the configuration database to the running database. The example configuration used in this course has the OSE port physically connected to the E-SC-E1. This is an Ethernet-based SFP port on the B, DL1-3R11. This gives the OSE a bandwidth up to 1.25 gigabits per second. This example shows how to provision and enable the SFP in the OSE port using the following parameters. Shelf 1 is a BDL1-3R11. Slot is always set to 0 on a BDL1-3R11. Since it is a single blade, all ports associated with it are on slot 0. Subslot must always be 0 when it is used in a command. Admin status up enables the port. After provisioning the SFP in the OSE port, use the command commit to copy the provisioning from the configuration database to the running database. This example shows how to provision and enable the SFP in the E/SC/E1 port using the following parameters. Shelf 1 is the B, D, L1-3R11. Slot is always set to 0 on a B, D, L1-3R11. Since it is a single blade, all ports associated with it are on slot 0. Subslot must always be 0 when used in a command. Admin status up enables the port. After provisioning the SFP in the OSE port, the command commit is used to copy the provisioning from the configuration database to the running database. The E-SC-E1 port is an Ethernet port and requires some basic Ethernet provisioning. This example shows how to provision the Ethernet parameters and how to enable the Ethernet interface using the following parameters. F-1/0/0/E-SC-E1. This is the port reference for the E-SC-E1 on shelf 1, slot 0, subslot 0. Admin status up enables the port. MTU is the maximum size of E-SC-E1 frames, which is 1800 bytes in this example. Speed is the rate, in megabits per second, at which the E-SC-E1 interface runs. After provisioning the Ethernet parameters for the E-SC-E1 port, use the command commit to copy the provisioning from the configuration database to the running database. A single optical transport system (OTS) entity is always associated with an E1 edge port. This example shows provisioning and enabling of the OTS for the E1 port in shelf 1, using the following parameters. OTS-1/0/0/E1 is the OTS entity in the E1 port on shelf 1. Degree number. 1 or 2 degrees are supported in software releases previous to release 3.1. OPE mode. OPE mode full is currently the only OPE mode option available. After provisioning and enabling the OTS for the E1 port on shelf 1, use the command commit to copy the provisioning from the configuration database to the running database. After provisioning the OTS, enable the optical multiplex system (OMS) for the E1 port's OTS, as shown in the example. After provisioning and enabling the OMS for the E1 port on shelf 1, use the command commit to copy the provisioning from the configuration database to the running database. Logical port L1 is an internal L100 port that connects the preamp to the WSS. Before allowing an optical channel, OCH, cross-connect along the traffic path, which could be either a pass-through cross-connect from degree 1 OCH to degree 2 OCH, or an add-drop cross-connect, the L1 logical port must be defined before services can be provisioned. This is the case for release 3.1 and earlier. The number of channels Num lanes must match the num lanes provisioning on the ports that are being cross-connected. After provisioning and enabling the L1 logical port, use the command commit to copy the provisioning from the configuration database to the running database. The next 4 slides show the minimum provisioning required to connect the FlashWave CDS used in this example network through the 4x16 splitter coupler and the 1x9 WSS ROB blade. To do this, first assign an optical channel to the E1 on the 1x9 WSS ROB blade to support the FlashWave CDS service. This example shows the following. OCH1 is assigned to the E1 port on shelf 1. Admin status, up, enables the OCH. Center frequency, means the center frequency of optical channel 1, in this example. After provisioning and enabling OCH1 for the E1 port on shelf 1, use the command commit to copy the provisioning from the configuration database to the running database. Next, the C1 on the 4x16 splitter coupler, shelf 2, slot 1, sub-slot 0, is provisioned. There is no need to assign it a channel center frequency, as that will be determined when a port connection is established between the C1 port and the E1 port on the ROB blade, which is shown on the next slide. After provisioning and enabling OCH-2/1/0/C1 on the splitter coupler, use the command commit to copy the provisioning from the configuration database to the running database. The port connection connects an edge port on the splitter coupler to a client port on the ROB blade, E1 to C1 in this example. After these ports are logically connected, cross-connects can be established that connect a client port on the splitter coupler to an edge port on the ROB blade. It takes 2 commands to establish a full duplex, bidirectional, connection. Each of the 2 commands establishes a simplex, unidirectional, connection. In this example, the first set command uses the following parameters to establish a unidirectional connection. CDS-add-D1-CH1 is the name given to the port connection. SRC-shelf2, SRC-slot 1, SRC-subslot 0, SRC-port E1 refers to a unidirectional source port on shelf 2, slot 1, subslot 0, port E1. This is the E1 port on the splitter coupler in this example. DES-shelf 1, DES-slot 1, DES-subslot 0, DES-port C1 refers to a unidirectional destination port on shelf 1, slot 0, subslot 0, port C1. This is the C1 port on the ROB blade in this example. After establishing a port connection between a splitter coupler edge port and ROB client port, use the command commit to copy the provisioning from the configuration database to the running database. The second set command uses the following parameters to establish another unidirectional connection. CDS-drop-D1-CH1 is the name given to the port connection. SRC-shelf 1, SRC-slot 0, SRC-subslot 0, SRC-port C1 refers to a unidirectional source port on shelf 1, slot 0, subslot 0, port C1. DES-shelf 2, DES-slot 1, DES-subslot 0, DES-port E1 refers to a unidirectional destination port shelf 2, slot 1, subslot 0, port E1. After establishing this port connection between a splitter coupler edge port and ROB client port, use the command commit to copy the provisioning from the configuration database to the running database. This example shows how to cross-connect the C1 port's OCH on the splitter coupler to the E1 port's OTS on the ROB blade, providing a completed path from the FlashWave CDS to the WDM network. In this example, the following parameters are used in the first command to establish one unidirectional cross-connect. Set fabric OCH-connection establishes an optical channel cross-connect for the defined source and destination ports. XCOM-CDS-CH1 is the name of this OCH cross-connect. SRC-IF is the source interface. OCH-2/1/1/0/C1 is the OCH that was created previously for the splitter coupler C1 port. DST-IF is the destination interface. OTS-1/0/0/E1 is the OTS created previously for the ROB blade. DST-OCH is the OCH that was created previously for the ROB blade. After cross-connecting the C1 port on the splitter coupler to the E1 port on the ROB blade, use the command commit to copy the provisioning from the configuration database to the running database. The FlashWave CDS now has a service path through the L-series equipment, and it has service, assuming its database has been provisioned. To provision the service for the Onefinity T310 shown in the example network earlier, repeat the actions from the last 3 slides, with different parameters for the following: OCH number and center frequency, OTS number. Client port references should be for C2 instead of C1. This lesson demonstrated how to log onto an L100, then do the following tasks. Show, provision, and delete a user. Set the TID. Set the system name. Define an L110 as a tributary shelf. Provision LCN1 parameters for DCN connectivity. Provision NTP servers. Enable fans. Verify current licenses. Provision an E1 and C1 port on a BDL1-3R, 11 blade. Enable the PIL1-3 PS2 blade in Shelf 2. Provision an E1, C1, and C2 port on PIL1-3 PS2 blade. Provision a C1 and C2 port on PIL1-3 PS2 blade. Provision the OSC. Provision OTS, OMS, and OCH for an edge port. Provision OCH for a client port. Provision a logical port. Provision a port connection. Provision add drop OCH cross connects.
The performance monitoring chapter describes the PMs that are available on the system and goes over how to view and reset the PMs.
Using the information contained in this lesson, students should be able to identify L-series PM commands and interpret responses, as described in the L100 L-series user manual. PMs can be obtained for WDM per channel optical power. For client ports, on the L100, it is for port C1 through C9, and on the L110, it is for port C1 through C16. For edge ports, on the L100, it is for port E1, and on the L110, it is for ports E1 through E4. For logical port L1, PMs can be obtained for WDM optical transmit-receive power for OTS, OMS, and OSC. PMs can be obtained for optical transmit-receive power on ports. On the L100, it is for E-SC-E1, or F-SC-E1. On the L100, 110, it is for E1/E1 through E4, and C1 through C9/C1 through C16. PMs are gathered into the following bins. There are 32 15-minute bins, numbered 0 to 31. Bin 0 contains PMs for the current 15 minutes. Bin 1 contains PMs for the 15 minutes previous to bin 0. Bin 2 for the 15 minutes previous to bin 1. Bin 3 for the 15 minutes previous to bin 2, and so on, ending with bin 31, containing PMs for the 15 minutes previous to bin 30. There are 6 one-day bins, numbered 0 to 5. Bin 0 contains PMs for the current day. Bin 1 contains PMs for the day previous to bin 0. Bin 2 for the day previous to bin 1. Bin 3 for the day previous to bin 2. Bin 4 for the day previous to bin 3. Bin 5 for PMs for the day previous to bin 4. WDM per channel optical power PMs are available for client ports, edge ports, and logical port. To view WDM per channel optical power PMs, use the command show table PM equipment. This example shows transmit and receive optical power for optical channels 1 and 46 in the 15-min-0 bin, which shows the current 15 minutes. Optical channel 1 is reporting PM valid, value of true for all 6 of its transmit and receive PMs, indicating that all 6 parameters for optical channel 1 are operating within the acceptable optical power ranges. Notice that the example shows optical channel 46 is reporting PM valid, value of false for its optical power transmit minutes, and optical power transmit max, PMs, indicating one of the following. Either the acceptable levels for these two parameters, -99.9 and 0.8 respectively, have exceeded equipment specifications. Or, some type of reset or restart has occurred on the bin, invalidating the PM counts until the appropriate time duration elapses. In this example, it is 15 minutes. Refer to the L100 L-series user manual for PM thresholds. To ensure that a false indication is accurate, do the following. First, connect all client-side and network-side fibers. Next, clear all PMs. PMs can be reset as a group, or individually using the request in a-PM command string. Then, wait until the PM bin's entire time period has elapsed. To view WDM line optical transmit and receive power PMs, use the command show PM-equipment. This example shows the optical receive power for the OSC for all the PM bins, since no specific bin is specified in the command. Note that bin 0 is listed first, followed by the other bins. There are multiple pages generated for this command, but only the first page is shown here. In this example, the OSC reports a PM value of 15.1 in the 15-minute 0 bin. The range for optical power receive OSC is -39.9 to 7.0, as listed in the L100 L-series user manual, meaning that this PM of -15.1 is within the acceptable range. Because it is within the acceptable range, it causes a PM validity of true. You can scroll through all the bins to verify all PM bins have a PM validity of true, and are therefore within the acceptable range. To view a single bin, use the command show PM equipment, and add the parameter time period index, followed by the number of bin you want to view. For an E1 or OSC port, WDM optical transmit and receive power PMs that are available are OTS, OMS, and OSC. To view port PMs, use the command show PM equipment. This example shows how to display port PMs for the C1 port on shelf 1, the 1x9 WSSROB blade, for only the 15 minutes, 0 bin. The PM shows minimum, maximum, and actual optical levels, for both transmit and receive on the specified port. All 6 PMs indicate true, meaning they are all within acceptable transmit and receive power levels for the 15 minutes, 0 bin, time period. This lesson demonstrated how to view and reset PMs. It also described the 3 types of L-series PMs. WDM per channel optical power, WDM optical transmit receive power, and ports.
The final lesson, maintenance, shows you how to use the system's alarms and LEDs to identify potential system issues, and then how to use maintenance commands to retrieve additional information to help you identify any issues.
Using the information contained in this lesson, students should be able to identify potential L-series issues, based on maintenance commands, alarms, and LEDs, as described in the Onefinity L-series user manual. The 1x9 WSSROB has multicolor LEDs that indicate the following. SYS LED, for the system. Green. Normal operation. Yellow. Not ready, warm-up or software download in progress. Red. Equipment fault or power-up state. Blinking red. Mismatch of equipment and attributes, MEA. ALM LED, for the alarms. Off. Normal operation or no power. Yellow. Minor alarm. Red. Critical or major alarm. OSC LED, for the optical supervisory channel. Off. Normal operation or no power. Green. Incoming optical signal operating normally. Red. Input port is down, either E-SC-E1, or F-SC-E1. E1 LED, for edge port. Off. Normal operation or no power. Green. Incoming optical signal operating normally. Yellow. Payload missing indication, PMI. High reflection, HREF. Backward detect indication optical layer, BDI-O. Red. WDM loss of signal. WDM power out of specification. C1 through C9 LEDs for client ports. Off. No power or unprovisioned. Green. Incoming optical signal operating normally. Red. C1 through C9 port input, down, or C1 through C9 port, power out of specification. Fan 1 and Fan 2 LEDs, for fans. Off. No power. Green. Normal operation. Red. Equipment fault. A fan failed, or was removed. Blinking red. Fan mismatch. Loss of LED activity may indicate that the PIU is in reinitialization mode, operator activity, and not necessarily out of service, OOS. The optical mux base blade has multicolor LEDs that indicate the following. SYS LED, for the system. Green. Normal operation. Yellow. Not ready, warm-up or software download in progress. Red. Equipment fault or power-up state. Blinking red. Mismatch of equipment and attributes, MEA. ALM LED, for the alarms. Off. normal operation or no power. Yellow, minor alarm. Red, critical or major alarm. Fan 1 and Fan 2 LEDs, for fans. Off, no power. Green, normal operation. Red, equipment fault. A fan failed, or was removed. Blinking red, fan mismatch. Loss of LED activity may indicate that the PIU is in reinitialization mode, operator activity, and not necessarily out of service, OOS. The optical mux base blade has multicolor LEDs that indicate the following. FS LED. Off. No power green. Normal operation yellow. Not ready warm-up or software download in progress. Red. Equipment fault or power-up state. Blinking red. Mismatch of equipment and attributes, MEA. ELED for edge. Off. No power. Green. Incoming optical signal operating normally. Red. E1 through E4 port input down. E1 through E4 port power out of specification. CLED for client. Off. No power. Green. Incoming optical signal operating normally. Red, C1 through C6 port input down. C1 through C16 port power out of specification. Loss of LED activity may indicate that the PIU is in reinitialization mode, operator activity, and not necessarily out of service, OOS. Before provisioning, check alarms to verify the health of the system. The command, show, alarm summary, displays a total count of any minor, major, or critical alarms. If alarm counts are displayed here, the command, show, alarms alarm list will display details about them. In this example, notice the alarm, LLDP fail, which is located immediately above the command, show, alarm summary. Since it is a warning, it is not included in the alarm summary, as the alarm summary has no counter for warnings. In this example, there is one alarm from the ETH-1/0/E-S-C-E1, which is the port connected to the OSC. This alarm indicates a failure with the LLDP, Link Layer Discovery Protocol. LLDP is a protocol that runs on the OSC, to discover the port on the other end of a cable connection. For this alarm, LLDP status would need to be verified on either end of the connection. Alarms and conditions can be found in the Onefinity L Series User Manual, Section 3.1.3. When backups are made, files are transferred using FTP to a directory on a remote FTP server. This example uses FileZilla as the FTP server, which is installed on a laptop. FileZilla is configured with the username, training, and the password, test01. Files are transferred from the L100 directory, that is named /var/ftp, to the default FileZilla directory on the FTP server. The FTP server program used in this example is FileZilla. FileZilla is launched, and then provisioned with the laptop's loopback address, 127.0.0.1. A FileZilla username, training, and the password of test01 is used in this example. The laptop's NIC card is the destination IP for the FTP. To find the IP address on a Windows laptop, open a command prompt window, and type the command, ipconfig. Backups are first generated and placed in the directory, /var/ftp, on the L100, 1x9, WSS, ROB. From this directory, they are FTP'd to a remote location on an FTP server. To transfer the backup file from the L100 to the FTP server, use the parameter, upload. Two actions are possible, upload and download. Upload will take a file on the L100, and copy it to the FTP server. Download will take a file on the FTP server, and copy it to the L100. After logging into the L100, use the command request db backup to create the backup file and put it in the /var/ftp directory. The example above names the backup file backup_11-14-2016.dbs. Backup files must always have a .dbs extension. After the backup is complete, it can be sent to the FTP server using the command request transfer FTP, as shown in the example. This command will FTP from the /var/ftp directory on the L100 to the FTP server at the IP address 10.1.101.74. It will put the backup file into the FTP server's default directory. It keeps the same name. Use the FTP server's username, training, and password, test01. The message, 100% of /var/ftp/backup_11-14-2016.dbs, upload is completed, means the L100 communicated with the FTP server and successfully transferred the backup file to it. The FTP server should also be viewed to ensure it received the file successfully. Verify successful transfer to the FileZilla FTP server using the following. The black line of text displaying, connected on port 21. The green line of text indicating that the L100 is logged onto the FTP server using the user account, training. The blue line of text indicating that backup_11-14-2016.dbs was stored, STOR, on the FTP server. Successful file transfer as indicated by the text, successfully transferred /test.dbs. The final check is to verify that the file is in the FTP server's download directory. This window shows the backup file in FileZilla's default directory, indicating a successful backup. The backup file being restored is loaded from an FTP server into the L100/var/ftp directory as follows. Request transfer, FTP, action, download local-file-path, /var/ftp, /L100 backup_11-14-2016.dbs, remote file-path, ftp, // training, test01, at 10.1.101.74, /backup_11-14-2016.dbs. The restore file is activated from the /var/ftp directory, using the following command. Request, db-restore, file name, L100 backup_11-14-2016.dbs, gdb check, true, sysname check, true. The restore can be activated and tested with a rollback timer, that will fall back to the old database, if the rollback time period lapses. Activating the new database causes a system restart, and all management sessions are dropped. To activate the database, use the following command. Request, db-activate, rollback timer 0.0.2.0.0.0. The rollback timer is cancelled manually after the restored database has been tested and approved. The rollback time frame should be long enough that the testing of the restored database can be completed. Users must log back onto the L100 to cancel the rollback timer. To cancel the rollback timer, use the following command. Request, cancel-rollback-timer, except, true. This lesson provided an overview of the L-series tools available for both scheduled and unscheduled maintenance activities including LEDs, checking alarms, backups, restore.
You've reached the end of the course, except for the final quiz. To start the quiz, click the Next button. After you're done, you'll see a slide with your results to indicate how you did. That's it for me. Good luck.